the resistor. Okay, right. Let us just wait. Okay, right. Okay, so last class we have started with what is called as electrical system building blocks, and we have discussed the three different types of the electrical system building blocks. Okay, so after that, if you remember, we went further with understanding the equations. Is it not? Okay, so understanding the equations. Which one we have done basically? The first one, what we have done is what is called as the RC circuit. Okay, so that is called as the resistance capacitor system. Okay, right. Now take the second one now as derive an expression derive an expression derive an expression for 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 a an electrical system consisting of resistor resistor inductor capacitor system consisting of resistor inductor capacitor system resistance inductor capacitor system. Okay, so now what do you mean by resistor inductor capacitor system now? Okay, so it is the R resistor inductor capacitor system. Okay, now we call this as what is called as the RLC system. Okay, yeah, so note down the circuit diagram. Over. Over, right? Okay, write down the figure the circuit indicates. Write down. Hello, hello.
Yes, sir.
Okay, the circuit indicates the RLC system. Circuit indicates the RLC system. Circuit indicates the RLC system. As per the Kirchhoff's second law, ಬರ್ಕೊಬಿಟ್ಟು ಹೋಗು ಯಾವ ಬೆಳಿಗ್ಗೆನಾ ಎಲ್ಲಿಗೆ ಹೋಗ್ಬೇಕು ಇವಾಗ? ಎಲ್ಲಿ ಇಲ್ಲೇ ಇದ್ದಾರಾ? ಪ್ರಿನ್ಸಿಪಲ್ ಆಫೀಸ್ಗೆ ಹೋಗ್ಬಿಟ್ಟು ಹೊರಡು. Right on. As per the Kirchhoff's second law applied to the loop, what is the input here? As known, input is V, output will be Vc. Okay. As per Kirchhoff's voltage law applied to the loop, what is V is equal to? Tell me, what is the equation for V as done in the last class?
IR, sir.
Huh?
IR.
No, equation for V first. Let us apply the KVL to the loop. The V will be equal to the algebraic sum of the voltages of all the components equal to the input voltage, correct? No, V will be equal to, go back and see the first equation, the previous one what we have done, previous component, RC system.
VR plus
Yeah.
VL plus VC.
VR plus VL plus VC. Okay, right. So what about the current passing through the circuit? Will it be same or will it be different?
Same, sir.
Okay, write down next line you write. Have you noted down this? Please note down whatever I am writing. Have you noted down this?
Yes, sir.
Okay, next line you write. Since there is a single loop, the current I will be the same through all the elements. Okay, right, that is known to us. So we'll write down, therefore VR is voltage across the resistor. What is voltage across the resistor? What is the equation with respect to current? What is the equation?
IR.
I into R. Okay, so the V is equal to I into R. Okay, right. Then VR, then VL. What is VL? VL is voltage across the inductor. Correct? What is the basic equation for voltage? What is VL? What is you go back to the basic component that we have discussed now, inductor. Okay, what is that we wrote? V proportional to di by dt, and proportionality constant if we remove, what we wrote? What we wrote?
1 by L.
Nodama, just
L.
check.
L into di by dt, sir.
L into di by dt. V is equal to I is equal to 1 by L. V is equal to L into di by dt. Okay, right. So L into di by dt. Okay, right. So now, therefore, Vc, it is already present in the output form, correct? No? So therefore, we directly write down V is equal to IR, correct, plus L into di by dt plus Vc, correct? No? Okay. Yes or no? Clear?
Yes, sir.
Okay, right. Now what we have to do now is we have to convert this into this equation. Okay, V is there, IR. Okay, now this we need to convert into what? Convert it into the form which consists of VC. Are you understanding? So this is already in the output. What is the output? Output should be voltage across the capacitor. Okay. So this you need to express IR. IR need to express in the form of VC. L and di by dt should be expressed in the form of VC. Okay. Are you understanding now? Okay. Are you getting my point?
Yes, sir.
Hello, others?
Yes, sir.
Okay, now IR, this you have to express in the form of VC. Okay, because you are getting the relationship between, you are writing the relationship between input and output. Okay, all the components, subcomponent should be converted in the form of VC. Okay, so third component is already in the form of VC. We need not to touch that. So first one and second one we need to do. Okay, right. Now what we can do now is, okay, we know that. Okay, but so I is equal to, okay, if we know the equation for capacitor, okay, what is I? I is equal to C into, tell me, C into d VC by dt. Okay, correct? Correct or what?
Yes, sir. Yes, sir.
Okay, now we can substitute the value of I here. Okay, then what we require? We require di by dt. Correct or what? Okay, so therefore you take the first derivative di by dt. What is di by dt? Tell me. Di by dt is what? Tell me. What is the derivation? What
V,
is the
sir.
huh?
C into D square VC by dt square.
D square VC by dt square. Correct or what? Now I value will substitute for this. Okay, so therefore, okay, so you write down V is equal to what? What is V? What was the equation we got? V is equal to IR. I am writing again IR plus L into di by dt plus VC. Okay. Substitute the value of I and di by dt to above equation. Okay, what is going to happen? V is equal to, okay, I is what? Tell me what is I?
C into dVC by dt.
C into dVC by dt into R plus L. What is di by dt? What is di by dt?
C into Sir, D C into square dVC.
D square VC by dt square plus VC. Okay, right. So we'll rearrange as per our differential equation format. Okay, rearranging V is equal to, okay, right, LC d square VC by dt square plus RC dVC by dt plus VC. Okay. Now, if you observe, the first term is also consists of VC, correct? First term is also VC. Second term is also we have VC. Third term is also VC. Okay, right. So this is the relationship. This is the relationship between input V and output VC, which is a second order, correct or what? Second order differential equation, which is a second order differential equation. Is it clear? Got it now?
Yes, sir.
Okay, right. Okay, right. Now, third one. Okay. Resistor inductor system. Resistor inductor system. Okay, what is this? RL system. Okay, right. Yeah. Note down this. Over?
Yes, sir.
Okay, right. Okay, write down. Okay, I want you to tell me completely the equation for this. Okay, write down. Circuit in, write down the thing. Okay, as done in the previous exercise, you write down. Okay, what is that you started? Circuit indicates. Write down. Circuit indicates the components of RL system. 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 Okay, right on. Next is what? As per the KVL law applied to the loop. Applied to the loop. Applied to the loop. Applied to the loop. V is equal to, what is V now? What is V? Tell me. V is equal to
VR plus V's.
VR plus
VL.
VL. Okay, right. Correct or what? Right. Here, in this circuit, input is what? What is the input? Input is, tell me, what is
Voltage.
input? Voltage. Okay. Output is
VL, sir.
VL. Voltage across the capacitor. Sorry, voltage across the inductor. Voltage across the inductor. Okay. Right. Now, what is VR? Now we'll substitute the value in terms of VR in terms of VL. Are you understanding? Okay. So now V input is already present in this equation. Okay. Output is already present. So this is not in the this one is not in the form of output, not in the output. So convert this into VL equation. Are you understanding? Okay, that's all. Okay, now we shall do that. What is V? What is VR? What is VR?
I into R.
I into R. Okay, VR is I into R. Okay, right. Now, can we substitute this here? Therefore, what is going to happen? Therefore, V is equal to IR plus VL. Okay. Can we call this as the final equation? Tell me, can we call this as the final equation? This is the final equation? This one?
No, sir.
No. Why? The first term is not in the form of VL. Yes or no? Okay. Right. Now we write the equation now. Okay. So write what is I for inductor? Basic. Tell me basic equation for I for inductor. Tell me. Go back and write. Tell me. Go
Sir,
back to
1 by L into integration of V
Yeah.
into dt, sir.
I is equal to 1 by L into integral of VL into dt. Correct, right? Yes or no? Okay. Yes or no?
Yes,
Yes,
sir.
sir.
Okay. Now, what shall we do now? Substitute this x because I is same. I is same for R also, for L also. Correct, right? Are you understanding? The value of I is same for passing through the resistance and also the inductor. Therefore, we can write, therefore, what is V now? What is V is equal to I into R. What is I? I is 1 by L. Okay. So we'll write R by L integral of VL into dt plus VL. It is already in the form of the output. Okay. So this is the expression for input V and output VL. Okay. This is clear?
Yes, sir.
Okay. Right. Okay. So we shall go to the now we have discussed what? Okay. Just observe. If you just observe now, I'm writing here. We have discussed RC, we have discussed RLC, and then we have discussed RL. Correct or what? Okay. Done? Yeah. Right. Next one you write. For the next one, for the following circuit, derive a mathematical model. For the following circuit, derive a mathematical model. For the following circuit, derive a mathematical model to relate input and output. To relate the input and output. To relate the input and output. Okay. Write down this circuit first. Over. Over.
Yes, sir.
Okay, right. Now below that you write, in this circuit, input voltage is what? Input voltage is V and output voltage is across the
VL and
capacitor. Okay. Okay. So this is the output voltage VC. Okay. Right. Now please note down this point as A, node point as A, this point as B. Okay. Right. Now this one is I1. Current through the inductor is I2. Current through the capacitor is I3. Are you understanding?
Yes, sir.
Okay, right. Now, in what way it is different from the previous? In what way this circuit is different from the previous? In all the previous three circuits we have done, no? In all the three circuits, how many loops were there?
One loop.
Only one loop. But here,
Two loops.
two loops are there. Therefore, the current is going to be, what is going to happen to I1? Current passing through the resistor will be distributed to where? Distributed to
Inductance and capacitor.
inductor and the capacitor. Therefore, as per the Kirchhoff current law, what is I1 is equal to?
I2 plus I3.
Okay, so as per the Kirchhoff current law, I1 is equal to I2 plus I3. Is my voice is clear today?
Yes, sir.
Okay, right. Okay, right down. Okay, next you write. Using the Kirchhoff's law, using Kirchhoff's current law, node B is taken as the reference node. Node B is taken as the reference node, and node A is taken as at voltage VA relative to B. At voltage VA relative to B. At voltage VA relative to B. Okay, right. Next, right? Applying Kirchhoff's current law to node A. Applying Kirchhoff's current law to node A. I1, tell me, I1?
Equals to I2 plus I3.
I1 equal to I2 plus I3. Okay, right. Now we'll write the equations for I1, I2 and I3. Okay, right. So what is I1? I1 is, what is I1? Current passing through? Tell me.
Resistor.
Both you write and tell me, so you will get an idea. Current passing through resistor. Okay, what is I? V is equal to I into R. Okay, therefore I is equal to V by R. Okay, correct or what? Okay, now what we need to consider here, we have input voltage V, correct? And at this point, what is the voltage? At the node A, VA is the voltage, correct? So V minus VA divided by R. Okay, V minus VA divided by R. Okay, right. Then I2, current passing through inductor. Okay, yeah. What is the equation for current passing through the inductor? What is the equation?
1 by L integral
1 by L into integral of
V
VA. Okay, VA means, okay, it is at node A. This is a reference node. Okay, A is the reference node. Okay, so VA into DT. Correct? Next. I3 is what? I3 is current passing through capacitor. Okay, what is the current equation for capacitor? Tell me.
into dV.
C, tell me.
C into
C into D
by
dVA, reference point, dVA by dt. Correct? Yes or no? Clear? Okay, right. Therefore, substitute. All of you substitute. Substitute into above equation. I1 V minus VA by R. I2 1 by L integral VA dt plus I3 C into dVA by dt. Okay. Over?
yes, sir.
Okay, right. Write down. As per the Kirchhoff's law, next. As per the Kirchhoff's law, VC will be equal to VA. Okay, VC is something but what? Output voltage. So this is the voltage passing through this. Okay. So this is your node point. This is your node point, that is voltage at A. Okay, that will be equal to VC. Okay, but VC is equal to VA. Hence V minus VC by R is equal to 1 by L VC dt plus C into dVC by dt. Okay, right. So we'll send R to the right side. Send R to the right side. It becomes V minus VC. It be R by L integral VC into dt plus RC dVC by dt. Okay. So rearranging V is equal to send VC to the right side, VC plus R by L integral VC into dt plus RC dVC by dt. Okay, expression relating input V and output VC. Clear?
Yes, sir.
Okay, expression relating input V and output VC. Clear now? Okay. Yes or no?
Yes, sir.
Okay, right. Now this completes what is called as the electrical building blocks. Okay. Now quickly, what have we done in electrical building blocks? To start with, remember, we have discussed the basic building blocks. That is what? Basic building blocks are inductor. Tell me.
Capacitor and resistor.
Okay, inductor, capacitor, and resistor. Okay. For all those equations, for all those elements, we have derived an expression for the current and then energy. That is one part. In the second part, we have done the mathematical equation, mathematical model for how many system? For RC system, for RLC system, and then RL system, and one more. Okay, so totally 3 building blocks and 4 equations we have done. Is it clear now? Okay, right. Now, before we go further to the next building block, okay, so we'll go one thing. Just note the heading as electrical and mechanical system analogies. Write down this. I'll explain what it is. Electrical and mechanical system analogies. What do you mean by analogies? What do you mean by analogy? Quickly. Tell me. What do you mean by analogy?
Similarity.
Similarities. Okay, analogies is nothing but basically a comparison, similarities, okay, differences, okay, between the electrical and mechanical system. Okay, now, as we have done mechanical system and electrical system, what are all the similarities between these two systems? Okay, that we'll write down. Okay, right. Now, just observe. Okay, note down this diagram. Have you noted this? Noted down?
No.
Oh, okay. What is the first diagram indicates? What system it is?
Spring mass damper.
What is that? Which system? It is a basic building block of
Mechanical.
mechanical system. Okay. Right. Then spring, mass, damper. Okay. Here, resistor, inductor, capacitor. This is what system? The electrical system. Okay. Can you quickly tell me what is the mathematical model for spring, mass, damper system? What is the mathematical equation for spring, mass, damper system? First equation we have done in mechanical system.
M square x by dt.
M into d square x by dt square plus
C into
C into
dx by dt.
dx by dt plus
A into x equals to f.
F. Okay, right. So what is the mathematical model for RLC circuit? Just now we are done, no? The third one, the second one. Second order differential equation.
V is equal to LC into
LC d square
dc by
dt square plus
R into C
dvc by dt plus vc is equal to v. Are you understanding? Okay, right. Now both of them are what? Both of them are what? Which order differential equation? Similarity I'm asking. Both of them are second order, correct? Second order differential equation. Both of them are second order differential equation. Okay, right. Now write down next the building blocks for electrical and mechanical systems. The building blocks for mechanical electrical and mechanical systems have many similarities. The analogy is as shown below. The analogy is as shown below. Okay, write down spring is equivalent to, write down, spring is equivalent to inductor, mass is equivalent to capacitor, spring mass, damper, dash part C equivalent to 1 by resistance. Okay. Then force equivalent to voltage okay analogies between mechanical and electrical system. Okay, right. Now this is about the mechanical system and electrical system. Okay, so we have another 3 left out. Okay, now till now just a summary. Okay, just I have some few time now before closing up. So we have discussed with what is called as the mechanical. Okay, we are done. Okay, let us not go too back. Electrical system building blocks we are done. Okay, right. So inductor 1 by L integral VL into dt I, correct? Okay, then capacitor I is equal to what? Capacitor equation I is equal to quickly
C into dV by
C
dt.
into dV by dt, dVc by dt. Then resistor, okay, resistor I is equal to V by R, correct na? Okay, so this is the first thing. Then next is going to be RC system, correct? Equation for RC system, then equation for RLC system, okay, then equation for RL system, okay, then next one more, fourth one we are done. What is that? Systems in present in 2 loops, correct or what? Systems present in 2 loops. Okay, now clear or what? Clear?
Yes, sir.
Okay, so these are all the equations what we have done in this particular electrical building blocks. Okay, now in the exam the questions are going to be maybe on this, okay, with a brief mathematical expression, explain the components or explain the basic building blocks under electrical system. Okay, so you write 1, 2, 3 and write all the equation. Okay, along with that also you have to write the energy equation. Okay, so write energy equations also. Okay, or else derive a mathematical model for RC system, for RLC system or RL system, or this is maybe they may give a diagram and ask. Okay, so this is about the mechanical and electrical system. Okay, so when we meet in the third hour, we'll go further with another hydraulic system, pneumatic system and thermal system. Total another 3 systems are there, so we'll take one by one. Okay, so in the third hour I think we can able to take hydraulic building blocks. Okay, right, so we'll stop at this stage. So now before I close further, any issues? So okay, now all of you are there. 1, 2, 3, 4, 5, 6, 7. Okay, right. So we shall stop the class now. Okay. So now we shall meet again in the third hour. Okay, right. Thank you.
Thank you, sir.